Welcome to Voice Bootcamp, a global name in unified communication. In this particular chapter, we will focus on voice gateways and signaling protocol. Signaling protocol is one of the most important part of the unified communication infrastructure. It provides a set of instructions between how two devices will communicate and the capabilities that they can support. The signaling protocol that we will talk about is H323 protocol, MGCP Media Gateway Control Protocol, Gatekeeper, and SIP gateways. Now H323, which is one of the most oldest protocol and the most mature protocol in the market that is still widely used by various vendors around the globe. Certain countries use H323 more than any other protocol that exists. So here we will discuss about the H323 protocol architecture, call flows, the codecs that are used and supported in H323, configuring H323 on Cisco gateways, and customizing H323 to fine-tune our voice network. We will verify the configuration by showing you real live configuration between a call manager and a gateway. Now H323 protocol is based on ITU standard, or International Telecommunication Standard Protocol. It is designed based on ISDN Q.931. Now those who are familiar with ISDN technology will see the configuration of an H323 quite easy. It is a mature protocol and widely used worldwide because it is one of the oldest protocol in the market. Now H323 is a vendor neutral. Basically most vendors H323 gateway more likely will work more likely we will work with each other compared to any other protocol that exists. Now it is a peer-to-peer architecture, which is one of the most important aspect of the H323. Now when I say peer-to-peer, so I'm talking about peer-to-peer being what this gateway has no knowledge about this side of the gateway network. When two gateways, such as whether the call manager or Cisco router, that communicate with each other, as long as IP connection is available and H323 process is running, it does not really care whether the T1 is up or not, or the voice port is capable of sending calls or not. So as far as the gateway concerned, that if there is an IP connection to the remote gateway, my H323 gateway is up and running. Now of course it does not mean the call will succeed, but at least this might be an issue, especially when you're doing redundancy or when you want to ensure that the call completion will succeed. So this is one of the problems with the peer-to-peer architecture. Each gateway act and function on its own. There is no dependency of the other gateway. Now with H323 gateway, when you have PSTN call coming in, whether via T1 or E1, the signaling, there's two types of signaling in ISDN technology exist, is Q.921 and Q.931. Q.921 is your layer 2 information of the ISDN protocol, whereas Q.931 contains layer 3 information, such as the phone number that you dial, the call that came, the caller ID where the call came from, the reason why the call was succeeded or failed, which voice port or channel it is using, and so and so. Now in H323, both of these protocol, either Q921 and Q931, will terminate into the router. Now what does that mean? It means that the router now has to process the message that is within these two protocol. Now we're more concerned about the Q.931 because that is the one that actually provide more information in terms of your called number and the caller ID. When H323 gateway receives the Q931 message, it has to extract the called number and find the destination where that called number is supposed to go. It could be an IP, it could be the call manager, it could be a phone that is attached to the H323 router, it could be another VoIP gateway, anything that is possible in terms of H323 world. So at the end of the day, the gateway itself must have knowledge about the dial plan or the number is going to match. So it is important that you must configure dial pairs in the H323 gateway as well as in call manager or any other remote gateway until it finds the endpoint. And it is supported on most Cisco platform. One of the one of the advantage about H323 is that it is self-sufficient dial plan per gateway. Self-sufficient dial plan means that each gateway you have more control over the dial plan than is if it was MGCP gateway. It gives you more specific call routing feature. There is no extra configuration that you have to do for an SRST, because SRST itself is an H323 product. Now, another advantage of H.3.3 network is that each gateway you can do translation based on the regional settings, and which does not depend on the call manager. So what really happens is, because in call manager the translation is very limited compared to the gateway level, sometimes in a multi-distributed environment it makes sense to use H323 gateway because you have more control over each gateway. Now, for example, a control means, let's say you have a gateway in USA, New York, and then you have a gateway in Germany. So obviously the gateway in New York will have, you may need to do translation, that is, to meet the requirement of the service provider in New York. And then again you have a gateway in Germany that requires totally different numbering schema compared to the one that you have in the United States. So translation per gateway gives you more control in terms of how the numbers can be manipulated. VoIP, in order to configure an H323, its configuration itself in H323 is not quite that difficult. Once you configure your digital T1 or E1, the next step is to configure dial pairs to route the call. Now, by default, most Cisco routers have H.3.3 protocol enable. You have the options to, of course, disable it should you choose to use different protocol. Now, even if you don't H323, even if you do not use H323, if you do not shut down the H323 protocol, it is available in the router by default, and therefore taking up router processor and memory space. So here, for example, I have a gateway. So I have a POTS dial pair that allows me to send calls to PSTN on this via port, and then I have a VoIP dial pair that allows me to send the calls to the IP network. So these are some of the example of an H323 configuration. So here's an example of a gateway configurations between two gateways and two IP phone. Should you need to send calls from this gateway to the second gateway, RTR2, you require a POTS dial pair and a VoIP dial pair. Now the POTS dial pair is required to assign an extension to the phone. So here, for example, I have a dial pair voice 20 POTS and I have a destination pattern 5001. That means when this particular router RT1 receive a call for 5001, it is going to ring whatever is connected to this port, which is in this case this particular phone. Now I have a VoIP dial pair called 30, where if you dial 3 followed by any 3 digit between 0 to 9, the call will be sent over the IP network to this IP address, which happens to be the IP address of this particular router. Now when the call arrive on this router RTR2, the H323 process will look at the packet and realize that it is destined for one of the extension called 3001, and therefore it is going to send the calls to this particular phone. Now for the calls to go to this direction, you of course need a VoIP dial pair again on this router. So each router must have a unique dial pair, a dial plan, and must have a full knowledge about how to route calls in both directions. Now the most configuration of the basic H323 gateway will serve most companies or providers. However, sometimes it is required that you may need to fine-tune your configuration to speed up the call setup process. H323 gateway may require tune-up to speed up the call setup or tear down an active call. Now when there is an incoming call, a timer will start to wait for an acknowledgement from the remote gateway. And if the remote gateway does not acknowledge, then the original gateway must act on it, because otherwise it might end up waiting for a response for forever. So timer can be used to reduce the speed of the call setup process, and of course you can also use to offer various codec by offering multiple codec choice. So here, for example, I have various configurations for H323. If by going to voice service VoIP, under H223, I can change the session transfer protocol. I can shut down the H223 process by typing shutdown. I can start the H223 process by enabling H223. Now, I also have various other options under H223 VoIP, for example, changing the slow start and fast start and so on and so. If you want to define a source address of an H223 traffic to be a particular IP address, then you can use that particular command called H323 gateway VoIP bind and the source address followed by the IP address. Now this IP address must be the IP address of this interface or the interface that you use to type this command in. Then I have a voice class H323 which is used to control the H225 timeout. For example, here I'm configuring H225 timeout TCP establishment 3 seconds. So if the TCP failed to establish within 3 seconds, I have the options to go to a backup mode, for example, or activate the backup link. H225 timeout setup 5. That means within 5 seconds, if I do not get an acknowledgement, I will of course activate my backup link. Then you can also create a voice class called codec, which allows you to offer multiple codec choice to remote gateway. So the remote gateway has the ability to decide which codec to use. So here, for example, I have a choice of codec G1, G711, G711 ULO, and then codec preference 2, G729R8. So once this classes has been configured, in order to utilize them, you must associate these classes to your dial peers. Now, in order for this to actually be utilized properly, especially the H223, you must have dial peers or multiple dial peers pointing to different gateways or call managers with the same destination pattern. The whole idea about H225 timeout is that if there's a call going to a particular destination, for example 9T, and if this particular gateway 135.1.1.1 does no response, obviously our goal is to go to the backup link. Now the backup link will only work if the destination pattern is exactly the same as the original one. So in the dial pair, you're going to say voice-class H223 and the number. This number represent the number right here. Sorry, in circle. Voice-class codec 2 represent the class right here. Now H223 has two methods of establishing a call, a slow start and a fast start. Now by default the fast start is enabled. In a slow start, what happens is when you initiate a call from a service provider, from a PSTN or cloud, your gateway will initiate H225 and H245 in two separate sessions. For example, first in the blue color, as you can see, H225 call setup has been in process of establishing it. So once that is done, then you have H245 capability negotiation established. So as you can see, the process of going through is almost like 12 different steps before media traffic has been actually established. So sometimes slow start can cause delay in establishing a call. In a fast start, both H225 and H245 will be offered at the same time, therefore giving you much faster call setup process. To verify the H323 configuration, you can type show H323 to see the status of the gateway and whether the gateway has been registered to any sort of gatekeeper or not, and so and so. Now I'm going to show you this configuration of an H223 gateway by logging into my the router and a call manager. So I will open up the PuTTY. Okay, so here I have a gateway called site C. I'm going to open my call manager to where I will be registering this. Now we use call manager 8.5 as far as one of the latest version right now, but this configuration will work with almost any version of the call manager that you have. So what I'll do first is type show run and show you the config of my controller. Right now there should not be any configuration of my controller. So first let me configure the PSTN site. So I changed the card type to E102 because in VWIG you need to define your what kind of card type you have, whether you want to use the card as a T1 or E1. Once that is done, I will define network clock participant WIG2, which is for clocking purpose, and then define the ISD and switch type primary 5 ESS in our particular lab. Once that is done, I will configure the E1 controller with the proper framing. Oops, wrong framing. And the line code will be framing and line code is basically the standard one. The important part is a primary time slot, the group, how many channels you want to establish. So we're going to establish 4 channel only. So no shut. So I have my basic configure T1 controller up. If I type show ISDN status, I should see my channel being established or multi-frame established, as you can see right here. So the first part is taken care of as far as the your T1 controller goes. The very first step of configuring H323 is by going to, well, not very first step, but some stuff that you can do. So let's show you voice service VoIP and then type H323. Now you are into the sub mode configuration mode of H323. If I type question mark, I should see various options. So here whatever the changes I do, these are global changes. For example, I can change H225 timeout either globally or per dial pair basis. If I want to do per dial pair basis, then I will use the voice class that I've shown you in the previous example. So for example, H225 timeout setup, and I'll say 5 seconds. This will apply to all the dial plan by default. I also have the options to change some other parameters. For example, session, transport. I have the options to choose UDP or TCP. Now, if using UDP may not work in most cases, so just be aware of that. I can also configure telephony compatible issue with the previous versions. So let's configure slow. Take a look at the slow start and fast start command. Call, and then you can say start, and you have the choice to decide slow or fast. So obviously I can, for example, define my slow start or fast start right here. Okay, once that is this is just an example. If you want to shut it down, again by going back to H323, you can shut down the process. Actually, you have to go back out of this. And you can say no H323. No H323 will make sure that the service is shut down. Now sometimes, like I said, if you're going to configure this gateway as a SIP gateway, why run H323? Now of course it doesn't make a huge difference in terms of load and whatnot, but just in case. Alright, so once that is done, I'm going to create a inbound dial pair for my H323 call. So the first dial pair I'll create is dial pair voice port 1. And first command is to enable incoming call number dot. This allows me to receive calls from PSTN on this particular dial pair, any call that is matter. And then I'm going to say enable direct invert dial. Once that is done, I will exit, and then I will create a VoIP dial pair. Now before I do that, I'm going to create my fine-tuning setup. So I'm going to say voice class H3231, and I'm going to change the setup to 5 seconds. H225 timeout setup 5 seconds. So if 5 seconds I do not get an acknowledgement from the remote site, I will move to my backup link. Then I will create a voice class that allows me to offer multiple codec, for example. Codec 1, and I'm going to say preference codec is G711 MULO, and the second codec options is G729. Now remember, by default, all Cisco dial pair, iOS dial pair, the default codec is G729R8. So often there's a potential of making a mistake of not changing the codec to the appropriate value. I'm going to here create a VoIP dial pair called 100 VoIP, and the destination of this call will be, let's say, 4 session target IPv4 and the IP address of my call manager. So this is the primary call manager 21. I'm going to associate the class that I've created. Class was voice-class actually, and I'm going to say voice-class H2231 voice-class codec also 1. Now because I have I'm going to have two dial pair with the same destination pattern, I must use preference command to decide which one, where the call goes first. So this one will be 0. Now by default all dial pair is 0 anyway, so you don't really need to type that command, but I do it anyway. Second, I'm going to create next dial pair, which will be exactly the same as far as the destination pattern goes. Session target will be IPv4 192.168.10.22, and voice class will be same thing again, 1. Voice class will be codec will be 1 as well. Now I will so here's my these are my configuration. Oh, one thing I forgot to do in this particular dial pair, which was configuring a preference of 1, because I want this one to be the second preference. So to show you the config, these are the 3 dial pair I just created with the appropriate settings. This dial pair is used for my inbound call. The second 2 dial pair is used for my outbound call to call manager. The destination pattern remains the same. The second one is a preference of 1, so therefore that will be the backup route. And the voice class codec and H223 codec is used to the 2 voice class that I have are used to manipulate the timeout and how many codecs to support. Now I'm going to simulate a call by first of all log into my remote phone. Actually I'm doing this lab remotely, so I need to log into my phone's backbone phone. We use an application called Verify inside, which is one of the very useful application for remote control and taking inventory of your call manager platform. Okay, so I am on rack 1 at this stage. So if I open the PSTN phone 1, I'm just going to make an inbound call. I'm not going to actually complete the call. I'm going to make an inbound call to see what do I receive on my PSTN. So that is my PSTN phone for particular rack 1. I will change the screen so that it refreshes. So what I'm going to do right now is I'm going to do a debug ISDN Q931, and I'm going to dial a number from the PSTN. So what I'll do is I'll bring the screen this side so that we have a better view, and this will come right here. Let me see if okay, not bad. Okay, so I'm going to do is dial a number from here, and see if the call hits my gateway. So the call did hit my gateway, as you can see. However, the call has failed. So let's analyze this. So as you can see, the call came in. This is my ISDN Q931. So the call fail was due to unallocated number, and the reason why the call failed was, look at the call party number. The call party number shows 24014001. Now let's take a look at this command, show dial peer voice summary, to see if do I have any dial pair destination pattern matching that particular pattern that just came in. So my pattern looks like 4 dot dot dot. So here it does not match the call number. So I have to do some sort of translation here to achieve this. So what I'm going to do, I'm going to use a very easy, cheap way of achieving this by using num expansion. And I'm going to say 2401 4 dot dot dot. I will convert this number to 4 dot dot dot. Okay, so in my backbone call manager, where I'll log in right now, sorry, my call manager 21, I'm going to log in, and I'm going to make sure that I have a phone with extension 4001. So I will try to dial again from my PSTN, and the call should hit my gateways. Let me verify my debugging is on. That is correct. I will click on dial number, and the call came in this time, and it's telling me that the network is out of order. Now this is a very important, because I have not added this gateway to call manager yet. So obviously the call will not go through, because I have to add this gateway to call manager. So to add this gateway to call manager, the very first thing that I want to do in my gateway is to go to the loopback address and define some H323 parameters, such as the bind source address. So I'm going to say bind source okay, so this is not the address that is defined for this. Oh, my mistake. It should be 66. Okay, so this is the minimum you need in your HQ, sorry, in the Site C router. So I'll show you the config right here. Now next thing I will do is go to call manager and add this gateway as an H323 gateway. So I'll click on add new gateway. So I will type the same IP address, and I can put the device pool. If I want any IE delivery or redirecting number, display IE, these are related to caller ID. So I will go ahead and save this. Now when you add an H223 gateway to call manager, keep one thing in mind, that this gateway will not be registering in call manager per se. It will be added and you will see the IP address, but the registration will always be unknown of this gateway. So when I list my gateways, I should see the IP address of the gateway right here. Okay, so let's try the call one more time and observe the message this time. Okay, so it's telling me the network out of order. So let's first make sure we can ping the IP address. Okay, so there is a problem. So network out of order means that there is a connectivity problem between or the IP address or IP routing issues. So it's very important that we solve that first before we go ahead and configure anything in the future. So here, for example, my IP network is not, for some IP route is not there. So there was a frame relay configuration issue. A command called frame relay interface delc was missing. So as you can see, my network is up. So is my root. Ping the call manager one more time. Connection is successful. So now I will dial the call again. So as you can see right now, the call has been connected. Right here it's telling me that call has been connected on port 0/2/0:0. That is your first port, and here you can see the connected state. So it will give you an options to see not only which port the call is connected, and also the reason the call was connected, for example. So here's the exclusive channel number 1 is being used. I'm receiving the proper information about the ISDN, the number that came in, which was a 8-digit number. I had to convert it to 4-digit using num expansions, the caller ID, and so on and so. So this is the configuration of an H223 network. For additional configuration, you can take a look at Voice Bootcamp UC Resource Kit, which is one of the very unique product in the market. Provide you over 300 plus video, scenario-based video that helps you understand this protocol more in and out. Like I said, this is a very unique product. Take a look at it at voicebootcamp.com under UC Resource Kit. Alright, the next topic is Gatekeeper. The Gatekeeper is designed to provide a centralized call management for H223 network. So Gatekeeper, for gateways to register to Gatekeeper before routing calls. One of the most important things that a gateway must register to Gatekeeper before they can route calls. Now, each gateway may have different capability. For example, some gateways with endpoint can register all the prefix to the Gatekeeper. Now, gateway with the FXS port, dial pair connecting to FXS port, or gateway with ePhone DN can register all their DN number to the gatekeepers. T1 port or E1 port dial pairs will not be registered to the gatekeeper because they are variable length and they are trunk line. Gatekeeper use tech prefix, zone prefix, and alias command to route calls, and gateway will always use gatekeeper for centralized dial plan. Will use, not always, sorry, my mistake. Will use gatekeeper for centralized dial plan and call admission control. Gatekeeper can provide bandwidth control as well. So before a gateway can communicate with the another gateway via the gatekeeper, they both must register by sending an RRQ message or registration request query. So gateway A, for example, send an RRQ message to gatekeeper. Gatekeeper will respond with an RCF or acknowledgement message. Now, as the gateway register, it will advertise all the prefix just like a routing protocol does, such as OSPF or RIP. It advertises all the prefix of the endpoint. Now, again, keep in mind when I say endpoint, I'm not talking about a gateway with T1 or E1 port or FXO port. I'm talking about a gateway with FXS and ePhone DN, where the actual phones or end device is connected. Now, when gateways register, the gatekeeper, what it does, it builds a dynamic table. Now, as you can see, the table. So there is a table right here that shows the name of the gateway, gateway B, the prefix that gateway B can serve, and the IP address of the gateway B. So what's going to happen is when gateway A has a call destined for area code 1416.839.1717, what happens is the gatekeeper will receive an ARQ message, admission request query, with this particular number. Now, first of all, before any lookup takes place, the gatekeeper will find out if the gateway A is able to receive and send a call. So there are some check and balance there available. So now what the gatekeeper will do, gatekeeper will then look up the table and realize that there is an entry for that area code 416. So gatekeeper will send a admission confirmation to the gateway A saying, okay, if you want to reach this particular network, please contact this particular IP address 1.1.1.1. So gateway A at that stage will send another H225 setup message to gateway B. So it is very important that the gateway A has direct IP connection to gateway B, even though it's communicating with gatekeeper first. Gatekeeper use some common terms to establish a call. Zone, which is a collection of nodes for routing calls. Zone can contain H223 client, call manager clusters, and gateways. Zone prefix, these are static routing. You can say that if the area code of the call is 416, send the calls to this gateway, for example. Or if the area code is 514, send it to Montreal gateway. Tag prefix are very unique string that we use to decide where the call will go to. Tag prefix is a way of routing a call by selecting the appropriate gateway. Now, for when the user dials a number, your originating gateway may include a tag prefix where the remote gateway is expecting. So, for example, gateway A and gateway B. When gateway A registers to the gatekeeper, gateway A can instruct the gatekeeper saying, hey, if you see a call with 2 hash, send it to me. And what happened is a remote gateway B, for example, when sending calls to gateway A, remote gateway will send calls to gateway A with the tag prefix of 2 hash. Gatekeeper basically does the routing. It does not really care what each gateway does with the 2 hash, or that is able to resolve that number or not. It just simply route calls. Default technology prefix is like a gateway of last resort. When a router does not have a direct network to route a call or does not have understanding about the route, it will always send the calls to default route. In gatekeeper, you have a very similar concept. You have a gateway that will register the gatekeeper with a tag prefix. Now you have a choice. You can say that that particular tag prefix, let's say 2 hash, will serve as a default technology prefix. When the gatekeeper does not have, like I said, when the gatekeeper does not have more specific route, the gatekeeper will choose the 2 hash and any gateway that is registered the 2 hash as a gateway of last resort. So therefore the call will ultimately go to that particular gateway. So here's an example of my scenario where I have 2 gateways registered to the gatekeeper. Here's a San Francisco gateway registered to the gatekeeper, and I have a Toronto gateway registered to the gatekeeper. I have 2 local zone and in this scenario I have a zone prefix saying any call with area code 1408 belongs to local zone SFO. Any call with a zone prefix of 1416 belongs to Toronto. Now a gatekeeper can contain two types of zone, a local zone and a remote zone. Local zone is a zone that gatekeeper manage, and a remote zone is a zone that is managed by another gatekeeper. When these two gateway register the gatekeeper, it uses a technology prefix of 1 hash to register, or 1 pound depending on which part of the world you're in. So both gateways in this scenario is registering with a 1 pound or 1 hash. In gatekeeper I have configured the 1 hash being the default technology prefix, so that means that is the gateway of last resort. So let's see what happened. I got two endpoints attached to the gateway. A call arrived to the gatekeeper with the ARQ number 141631330001. Gatekeeper looks at the number and realizes the technology prefix is not included in this particular message. So therefore I'm going to have to further analyze the call. So then it's going to say, does the zone prefix match occurs? Well, if you analyze the number 1416, gatekeeper try to match that number against the local zone that is configured in Toronto because of the zone prefix 1416. So for example, this number will be matched against this particular 416. So it match does occur, and it realizes that the target zone is a local zone, so it does not have to send a location request query to a remote gatekeeper. Local zone Toronto is a local zone. Toronto is a local zone. Now the number is not registered. Like I said, remember the gateway with the endpoint such as FXS or ePhone has the capability of registering the endpoint numbers. Well, in this scenario this is not the case, so the gateway did not register any endpoint. So because the number is not registered, then the system will say, was the technology prefix found in step number 2? Well, in this case the answer is no. Now the last step, or step number 8, to see if the gatekeeper has a default technology prefix configured. Well, in this case yes, it is, because it is 1 hash. So what happened? The gatekeeper will select the Toronto gateway to route the call. Now the funny keep a look at the interesting part here. Both gateways register with one hash. So why is that the gatekeeper selected the Toronto but not SFO gateway? Well, the reason behind that is your local zone is pointing toward the Toronto side. So the one of the most important part of the gatekeeper is when two gateway register to the gatekeeper with the same technology prefix, the gatekeeper will use zone prefix to decide the direction of the call. So two gateway register to the gatekeeper with the technology prefix, the gatekeeper will use zone prefix to decide to route the call. So the call finally established and it goes through. Second scenario, where the gatekeeper is actually does not have the default default technology prefix configured. However, it does have is receiving the call with the technology prefix. So here's an example of call arriving with ARQ 1 hash 141631330001. So gatekeeper looks at the number, realize the technology prefix is found, which is yes. Hop off prefix is configured, no. Hop off prefix is basically a more policy based routing. You can configure the gatekeeper saying, well, if you receive a call with a tech prefix of 1 hash, send the calls to this gateway or this zone. So it's more like a policy based routing. Zone prefix match, in this case yes it does, because of its Toronto 416 is a Toronto local zone. Yes, it is. Is the number registered in this scenario? No, it's not registered. Was the technology prefix found? Yes. And the call will select that gateway because again tech prefix was found and the zone prefix is directing the call to Toronto. Again, keep in mind, Zone prefix is used when to gateway has the same tag prefix registered into the gatekeeper. The last call, which focus on what the endpoint numbers is actually registered. So this case, the call came in with the number, technology prefix was not included, zone prefix match occurred, target zone is Toronto, Toronto is the local zone, number is registered, and the call goes through. So when the endpoint on the number is registered, what happened is the call process is much faster. Call process is much faster. So configuring gatekeeper is example. Gatekeeper is one of the most difficult concepts for some people to understand, but it is one of the most easiest one to configure. Now, once the gatekeeper configuration is done, you define a local zone. If you can type zone under gatekeeper, you can type zone local followed by zone name. So that XXX is the name of the zone. Domain name.com, which is irrelevant, you can type any domain name you want, followed by the IP address. Then you have to configure remote zone, you type zone remote YYY, and then to define the domain name, followed by the IP address of the remote gatekeeper. Now, to define a zone prefix or the static routing, you can type zone prefix followed by the zone name, and then the phone number 416 followed by 7 dots or 8 dots, for example. Now here I am sending calls to call manager. For any call starting with 416, going to get CCM trunk 1 with a gateway priority of 10. So 10 is the highest priority, 9 is the second next priority. So to register a gateway to the gatekeeper, I typed on the gateway side, I will go into the loopback interface. I will define my VoIP interface, H223 gateway VoIP interface. This allows you to run H223 process on that particular loopback. Next is to define an alias, H223 gate ID UKGW. That means that the gateway name will be identified as UKGW. I will define the zone name voice rec XX followed by the IP address of the gatekeeper. So this tells the gateway that go to this particular gatekeeper xx.11.11.11 and register to the zone voice rec XXX. Then I will register myself with the tag prefix of 1 hash. So therefore gatekeeper will send any calls with the 1 hash toward this particular gateway. Then to initialize this gateway, you type no gateway gateway, and this will initialize the registration of the gateway to the gatekeeper. Now obviously to send calls to the gatekeeper, you must have a dial pair. So in this case I have a dial pair called 3000, a typical destination pattern, and then I'm going to say session target RAS. Session target RAS basically advises the gateway to send the calls that start with 3 dot 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 or 5 dot 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 toward the gatekeeper, which is registered through the loopback interface. And I'm going to send tag prefix of 1 hash for any outbound call. So the tag prefix that is configured under the loopback, it is there to influence the inbound call toward this gateway from the gatekeeper. The tag prefix that is configured under the dial pair, it is to influence outbound call toward the gatekeeper going to the remote gateway. It is very important that each remote gateway, whether it's a H223 gateway or the call manager, to remove the tag prefix before the call hits the endpoint. So to troubleshoot gatekeeper, you can type show gatekeeper status, which will give you the status of the gatekeeper configurations, gatekeeper whether it's up or not. If you want to see a particular zone and see what the zone has been is enabled or not, you can type show gatekeeper zone status. To see what is registered to the gatekeeper, you can type show gatekeeper endpoint. This will tell you that what are the endpoints or gateways such as a call manager or H223 gateway that is registered. To see what are the tag prefix that has been registered, you type the command show gatekeeper GW tag prefix. Now debugging gatekeeper is very important thing. Debugging gatekeeper helps you troubleshoot the calls, why the call failed. So one of the most important debug is debug gatekeeper main 10 or main 5. Now obviously the 5 and 10 basically gives you a little bit level of detailed information that is output. You can also do a debug RAS, which is to debug more detail as to why the call what is going on in terms of HTTP, the gatekeeper packet. So these are some of the troubleshooting tool commands that can be used to ensure that your operation of the gatekeeper goes smoothly. So what I'll do right now is show you the configuration of the gatekeeper. So first of all, I will configure gatekeeper on my router, HQ router. So first thing first, type gatekeeper. I'm going to define a local zone, local GK. I'm going to call this cisco.com and the IP address of my loopback interface. This is the basic configuration that I really need. Then I'm going to configure a remote zone called bbgk cisco.com, which is the IP address is 135.11.11.11. Then this is basically the basic command. So what I'm going to do, I'm going to say any international call zone prefix bbgk 011, which is the international call in North America, send the calls to backbone gatekeeper. Any call with any call with 2 dot dot 200 2 dot 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 or 3 dot dot dot, I want those calls to go to call manager. So zone prefix GK 3 dot 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 prefix GW priority 10, and I'm going to call my trunk name as trunk_1. Now I can have the same thing for trunk_2 with a priority of 9. So of course for each prefix in call manager we're going to do this toward the call manager. Now next is the last. Any call with starting with 4, the call should go to UKGW, or actually let's call this site C JW. Oops, my mistake. Must remove this command. So what I'll do, because I already have 3, it's supposed to be 4 dot dot dot. Okay, no shutdown, type show run. And these are my gatekeeper settings. Okay, it has removed all the configuration for site C, the call manager 3 dot dot dot, so I will have to type those command back. So what I'll do is go back up and type this command. I'm basically copying and pasting those 2 commands that got accidentally removed. Okay, just shut it down, no shut. So if I type show gatekeeper status, this is one of the commands that I have. As you can see, the gateway status is up. Of course, there are some advanced features of gatekeeper such as load balancing, flow control, security, whether it's enabled or not, limiting the bandwidth. Right now I have unlimited bandwidth. So if I want to limit the bandwidth, for example, I go to gatekeeper and I'm going to say bandwidth total default 512K. So this show gatekeeper endpoint status. As you can see, my total bandwidth available to remote site is 512K. Now if I want to limit bandwidth per zone, then I have to go to this is for remote zone, remote bandwidth only. Alright, now next thing I'm going to do is I'm going to open up another window and I'm going to register the site C router. I will go to UK. So I will follow the same configuration. I will go to config T, interface loopback 0. I will say H323 H323 ID VoIP ID. I'll call this site C GW. GK is the name of the zone. IP address is the IP address of the router. And I'm going to register myself with a tag prefix of 1 hash. Exit, type no gateway and gateway. When I do that, it will give me a message saying the gateway site C has been registered with the gatekeeper GK. If I type show gateway, you will see that the gateway status is registered to the gatekeeper. Okay, quick note, if I type show gatekeeper endpoint, which is to show all the gateway that has a registered, so as you can see I have a gateway that is registered right here, 142.1.66.254, and obviously the IP address of the the RAS signal and so and so. Now the call, notice there is nothing else is registered. Even though this is a site C that has dial pairs for E1, there is no E1 configuration or dial pairs registered to this. So if I type dial pair area, as you can see, doesn't exist. Alright, so what I'm going to do is modify, I'm going to remove these two dial pair, otherwise it's going to cause some problem. I'm going to create a dial pair 3200 VoIP, any number starting with destination pattern 3 2 dot dot, session target RAS, tag prefix. Now call manager will register with the 2 hash, so I'm going to use 2 hash here. Exit. I'm going to create a num expansion to remove the 1 hash as the call comes in. 1 hash 4 dot 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 converted to 4 dot dot dot. Okay, so my site C is done. Now I will log into my call manager. On the device menu, go to gatekeeper. First thing I'm going to do is add a gatekeeper. So the gatekeeper type will be an IP address will be 142.1.64.254. So the gatekeeper has been added. On the device menu, I will create a trunk. So the trunk basically decide which gatekeeper zone to join. I will select H225 trunk. Now the device name, I will call this trunk because that's what I defined right here on my zone command, right, as you can see that trunk, there you go. I will call this site C, device pool um, pretty much same simple. At the bottom of the page where I have under inbound call, I can do significant digit of 4. That means only the last 4 digit is relevant to me. Anything else will be stripped off. And under the gatekeeper information, I'm going to define the IP address of the gatekeeper, terminal type, prefix will be 2 pound, because this is what tells the call manager that to the gatekeeper, saying if you see a call with 2 hash or 2 pound, send it to my direction. Zone name is GK. Is a case sensitive, keep that in mind. So I'll save the configuration and I will click on reset. So if I type here show gatekeeper endpoint, you notice that there are 2 additional endpoints, trunk underscore 1, trunk underscore 2. So trunk underscore 1 is a publisher, trunk underscore 2 is a subscriber. Now where is this 1 and 2 really coming from? Well, the system is adding that in advance. So but what does those 1 and 2 represent? If you go to the system menu and you click on Cisco Unified CM, you will notice that there are 2 servers you have, pub and sub. So if you click on the pub, this CTI ID that is in the database, right, 1, is what shows up on or appended to that particular name that you define trunk. Alright, now that I have my trunk, I have my gateways. What I'll do is that I'm going to quickly show you an endpoint how the phone numbers are registered. So in the UK, I'm going to quickly run a telephony service setup. Okay, this is kind of an older configuration. What I'll do, I'll run a telephony service. IP source 102.66.254. Okay, so I have one extension called ephone1 4001. If I do right now, if I do show gatekeeper endpoint, you notice how 4001 shows up. See, before it was not there. So as soon as I added an extension, which is an endpoint, it immediately shows up right here. Alright, to complete this exercise in Call Manager, I must create a route pattern. First of all, I must remove a pattern, because otherwise it's going to cause some problem, which is the number 4001 that I used as an example before. This was used, line 2 of this particular phone had 4001, which was added to testing purpose, so I must remove this, because right now what I want to do is any call with 4001 must use a gatekeeper. Okay, so simply create a route pattern. For XXX and send it to the trunk. Now keep in mind the gatekeeper is expecting a tag prefix. So show gatekeeper GW will show you the tag prefix that are registered by each endpoint. So what I need to do is make sure the tag prefix is configured properly. So in this particular number, when I'm sending call with 4xxx, I must ensure that on the called number I include the tag prefix of 1 hash. So the call will go out as 1 hash. Okay, so this is your basic configuration of your gatekeeper. For additional configuration of gatekeepers and various scenarios, I would strongly recommend you to take a look at our UC resource kit, which contains over 300 videos on the entire Cisco Unified Communication platform, including a dial plan dedicated to videos for that. Shows you how to use advanced feature of gatekeepers and route calls with redundancy in mind. The next topic is SIP. SIP, which is a standard IETF protocol designed based on existing protocol like RTP, RTCP, HTTP, SDP, DNS, SAP, MGCP, and RTSP. These are most common protocols that are used in the internet world, and these are the protocols that is what SIP is based about. SIP is supported on most Cisco platforms. It is a peer-to-peer architecture just like H323, and SIP use ASCII-based text-based messages. Because it is using ASCII-based text-based, it is much faster to operate. SIP, which is used to determine the location of target endpoints. It uses SDP to initiate to discover media capabilities. The ability of a target has 3 conditions: either the target is not reachable, already connected to a call such as busy, or no answering. SIP signaling will establish a session between a communicating endpoint, handles transfer and termination of a call or calls. SIP has various components that works together: a SIP proxy server, user agent, SIP gateways, SIP register server, location server, and redirected server. A register server is used to accept registration requests from end users. So when you open a SIP client and you want to register to a server, most likely you want to register to registration server. Once you are registered, to make any call, you will communicate with proxy server. The proxy server is responsible for relaying communication by acting as a client server between the endpoints. It does not keep any session state, and it is transparent to end user. A redirected server is used to redirect callers to other servers that can serve the call better. For example, if a North America user is trying to dial a number that belongs to India, it makes sense to redirect that call to a server that is closer to India. Location server that actually maintain the user accounts, where each location, North America location, contains list of all the user accounts that are in North America. These servers can be combined into a single platform, or you can run separate individual servers maintaining each role. SIP has various format you can register, you can connect. A SIP call flow can be direct between 2 SIP gateways, such as gateway to gateway, where you have 2 Cisco routers connecting over SIP. In this case, a Cisco IP phone will initiate a call. The gateway will initiate an invite message. So in this case, in step number 2 is notice a gateway initiated invite message to this particular gateway. Gateway will advise the originating gateway that okay, I'm trying the call. It will then send a ring back, and ultimately when everything is okay, it's going to send an acknowledgement saying 200 okay. Think about 200 okay, that is your HTTP GET method, and then a message basically. Then an acknowledgement is sent back to the termination gateway saying okay, fine, I have received your signals. Once everything is fine, RTP session will be established. RTP is done through media traffic or UDP. Once the RTP call is hung up, then again the signaling comes into play, which is to say bye and acknowledgement that particular bye message. So this is a direct communication between 2 gateways. Whereas if you're going to use a proxy server, a proxy server basically what it does, it kind of act as a relay or secure board or firewall, you can say, where originating gateway is hidden behind the proxy. The termination gateway will see the IP address of proxy server being the originating gateway, but in reality the originating call was from this particular device. Then you have SIP redirecting server. SIP redirecting server is basically when the call comes to the proxy server, at some point the system will tell the proxy server will tell the gateway that, hey, go contact this guy directly, rather than proxy handling the call for you. Now SIP addressing are in a format of URI, Universal Resource Information, which is basically name at domainname.com, or the E164 number. The telephone number in SIP environment is as follow: SIP followed by the number, add the domain name and the user type. SIP has various offers, which is before the call established. Now think about offers like a capability negotiation. Gateway A and Gateway B. Gateway A wants to send calls to Gateway B. Now Gateway B, before the call is established, the both sides will negotiate capability. So what happens is the originating gateway waits for this destination gateway or the termination gateway to send its capability first. So this is called delay offer. Delay offer is where the originating gateway analyzes the media capability received from the termination gateway, so that it can decide what capability to use. Early offer is when the originating gateway sends the capability along with the invite message, so that remote gateway decide what capability to use to establish the connection. Early media is when RTP channel is established before the call is even considered to be connected. The reason for that is sometimes certain gateways require the use of DTMF signals in advance, so that the IVR application function properly. So these are some of the capability messages that can be carried across your SDP channel or session discovery channel protocol. To configure SIP is quite straightforward. If you are going to register Cisco router to a SIP server, you will go to SIP _ISCO UA, then define the authentication string that is provided to you by the service provider, and the registration IP address as well as the SIP server IP address. The dial pair is pretty straightforward. When you create a dial pair, just simply change the protocol type. By default, the dial pair protocol type is H323. To convert to SIP, you simply say session protocol SIP v2, and the target will be SIP server or the IP address, depending whichever method you use. Now SIP does have the capability of supporting some ISDN features, such as a calling name display, block caller ID when the privacy exists, substitute the calling number for a call display name as if the display name is unavailable. Sometimes you don't want the user name to show up, you want the number to show up. The SIP can do substitution for that. To enable SIP IP phone to display caller name identification, simply follow this command: voice service VoIP SIP for signaling forward unconditional, and then under the D channel you say ISDN supplementary service name calling. Some of the show commands that are available in SIP, you can type show SIP UA service, which displays the status of the SIP service. Show SIP UA status shows the status of the user agent, and register status will show you the display the status of the E164 number that the gateway has registered with an external SIP proxy server or registration server. So these are some of the commands that you can use to debug as well as analyze your configurations. So now I'm going to show you how to configure SIP gateway on my UK router, site B router. Okay, so what I'm going to do is I'm going to log into my site B. So before I do that, I'm going to create a SIP trunk in call manager. You must create a SIP trunk in call manager. Trunk name here could be anything you want. I'll call this site B. And simply define the IP address of the SIP destination. Now in this case, the IP address is going to be the router IP address, 142.102.65.254. And save. Oh, sorry, you do need to define the SIP profile and SIP trunking. Right here. So once this is done, I am in the router right now, which is the most important part of this module, is to configure SIP here. So define the card type first. Define network clock participant. And define your ISDN switch type. Now configure the controller. Define your framing and line code. Now define the time slot 1-4. No shutdown. Will establish the channel. If I type show ISDN status, it says TE unsigned. Okay, there you go. Your layer 3 layer status is up now. Multi-frame establish. Okay, once that is done, SIP configuration is very straightforward. You can go to voice service VoIP and you can say SIP, and you have various options in SIP. One of the most important thing is that I like I wish I would do always is called the bind control address. I want to bind all traffic to the source address of your fast Ethernet. Actually, site V use VLAN interface 102. My mistake. I think it's 302. 301. There we go. 301. So I have to bring the interface up, so I will take care of that right now. Okay, so my interface is up. Next, just simply create dial pair, ports, direct inward dial, incoming call number dot. This allows the inbound calls to come in. Next, I will create dial pair VoIP, 100 VoIP. Destination pattern would be destination pattern is 3 dot 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 session target IPv4 call manager IP address session protocol SIP version 2 and DTMF SIP notify. DTMF allow you to carry the DTMF signals across the SIP message. Okay, once this is defined, I'm going to use codec G711. Now, using my PSTN configuration, I'm going to debug ISDN Q931 and I'm going to make a call 1972 301 3001. So let's see what happened to this call. So as you can see, the call did arrive as this number, so we have to now convert this number to PSTN. Anyway, this is example of how you configure SIP signaling. As you can see, the call did try to reach the call manager because it's telling you that unallocated number. So what I'll do is that I will type num expansion. The most easiest way is to convert this number, oops, one extra digit, and if I redial, again this is kind of the same thing. We redial, it says something not available. Again, we have to troubleshoot that in logger, but the idea is the call is going through call manager. I'm going to do a debug voice CC API in out. So call is hitting. This is a debug message where you see the translation occurred and the number was converted to 3001. Right now there's no phone registered with that number, so therefore the call is not going through anywhere. Destination 3001. Well, the number is registered but the phone is not, so therefore the call will not successfully complete. So this is the basic configuration of a SIP trunking. Again, if you want to see more video on this, you are welcome to take a look at the EC resource kit that contains over 300 video labs designed based on scenario, based on actually customer requirements to help you get through most of the advanced configuration of SIP trunking. The next topic is MGCP gateway. MGCP gateway is one of the most easiest gateway to configure and manage because most of the configuration is centralized. In MGCP gateway, you have a Cisco router that is acting as a voice gateway controlled by the call manager, which is acting as call control device. Now, call process is done by call agents such as call manager. MGCP use the endpoint connection to construct a call. Endpoints such as a source of the data or destination for data such gateway. Logical, you have a physical and logical locations in a device such as your T1 and E1 ports, the physical port, and then the IP address of the gateway is a logical. The connections are point-to-point, gateway to call manager, and multi-point, or call manager to multiple gateways. So to configure an MGCP on the router, one of the most important thing is the host name of the router, because the host name this is the MGCP domain name. If you have a command called IP domain name cisco.com, then the MGCP domain name will be hostname followed by .cisco.com. Once you define that, then you type MGCP call agent to decide what is your the call control device. Once you define the primary call agent, the IP address of the primary call manager, you bind the source address as well, source and media traffic for both. Bind the media and control source address to the loopback. If you have a backup call manager, you can type CCM manager redundant host followed by the backup call manager IP address. CCM manager MGCP basically defines what version of the call manager to use, and the fallback command is used for SRST. When the gateway loses connection to call manager, it has the capability to fall back. The difference between an HTTP gateway and MGCP gateway: when it comes to T1, the primary time slot must include service MGCP at the end. Now, to do a PRI backhauling where the D channel is terminated into call manager, under the D channel you must type ISDN bind L3 CCM manager. So this is a configuration of MGCP in the call manager side and in the router side. So this will basically required prior to adding the call manager end of it or call manager end of it. Information here is it can be done automatically using call MGCP config server CCM manager config server command. I'll show you now how to configure MGCP on the router. I will configure MGCP on the HQ side. I'm going to define network clock participant, week 2, define ISDN switch type, go to controller T1, define my framing, line code, and primary time slot 1-4 service MGCP. No shut. Define my D channel configuration, ISDN bind L3 CCM. Then you type your MGCP configuration, CCM manager, MGCP call agent, redundant host, the backup call manager, music on hold if you want PSTN to receive music on hold, and CCM manager fallback for SRST to work. Once this is done, type MGCP call agent, IP address of the call manager, and the bind control. So in here, bind control is a source loopback 0, media source loopback 0. One of the most important commands is to type the MGCP to activate it. Once this is done, you come to call manager, add a gateway, the MGCP gateway type, in our case we're using 2801. You can type show diag or show inventory to identify that. Use MGCP protocol. Domain name will be HQ in our case, and it goes to HQ group. We're using because we're using 2801, it is on the motherboard, so we'll save the command. So here we'll use the subunit configuration. You can type this show diag to find out your subunit configuration, and you'll notice that the T1 configure port that shows up here matches exactly the one that I have on my router. So I click on the port. I must define the signaling type, which is PRI. Alright, now the device pool again must belong to particular site, HQ, because this is HQ gateway. Important thing about MGCP gateway is a channel selection order. It must be top down because we are using only the first 4 channel. So if I say bottom up, the system is going to try to send the calls from the top bottom channel. Significant digit is 4. I will select all this IE delivery and save. Once you save, you reset this gateway. Here you can type show CCM manager on the router, and it will tell you that MGCP gateway is registered to the 22. The reason why it's registered to 22 was because the 22 or subscriber is my primary call manager. So let's take a look at the port to see if the port is registered. Okay, so as you can see, it is registered. Now, however, it's registered with the wrong IP address. It's supposed to be registering with a loopback, but it ended up registering with a fast-t. So to fix this, I must type no MGCP bind control source loopback. Oops. MGCP bind media source loopback. Type the command MGCP and reset this. This will fix the IP address problem. See, you can see it's fixed the IP address problem. Obviously, it's going to take a little bit of time to register. Once this is done, you can type show ISDN status. You notice how it says deactivated. So type show run to make sure we know what information is missing. Okay, so the configuration is there. However, due to some PSTN problem, my PSTN router may have caused this shutdown status issue. But as far as the configuration goes, it is it's configured on the router side. You can type MGCP settings, and these are the configuration that you need on the router. So there are more MGCP configurations on the gateway configuration on our EC resource kit. Should you require more advanced technique, take a look at that product. Is available on voicebootcamp.com. This will conclude our lecture on DVD for chapter 4 for CCNP+. Thank you.